We are finally live after 20 minutes of trying and failing to log in. But all that matters is that we are here now. In everyone. Tonight, we are giving Epsilon Delta another try. Hey Dan, how's it going? Welcome on in. I'm gonna spend the next couple minutes waving at clicking on the wave button for the chat, and if I can't, and I for some reason I can't click the button that says wave, I'll wave at you now. Hi everyone. Doing good. How about yourself? I'm doing good, Dan. How was your weekend? Do anything fun or exciting? As you are joining in, let's go ahead and see those hearts. Let's do a mad tap of that like button. Yeah. So yeah. So it took me so I click on the button that says TikTok live studio, and it's like, okay, do you want to get in? And I said yes, and it says, oh great, now we're gonna update. A couple minutes spend on the update. Okay, no big deal. So then it says, then it restarts, and it says, please log in. So I log in. So I use my login credentials. Maximum attempts allowed. Please try again later. I'm like, you've got to be kidding me. Long story short, it took me about 20 minutes to finally log into here. But such is life, and the most important thing now is that we are all here and ready to learn. Or at least, I hope that's the case. Thank you all for the likes. And I am going to say hi. I'm going to click on the buttons, as many as I can. Before we start again, I'll wave at those who I can't wave at by clicking the button. Yeah, welcome on in, everybody. How was my week? Yeah, I've been gone the last couple days, so um, yeah, I don't know why I've been extremely tired like the last 2 days. So that's why I've been gone. But here I am back again, well rested and ready to go. And speaking of ready to go, as soon as we hit 1K likes, because I know you all can do it, we will go ahead and get started. So I just found out on Saturday night or Sunday morning about about these things called subscriptions. I don't know if you've heard you've seen them before or not. But I'm trying to figure out something, and I want your help with it. What are some things that you'd like to see me if I did subscriptions or the new super fans that are going to start, I think, in a couple weeks? What are some things that you would want me to include in that, or things that you would want to see in that? I have a couple ideas, but I want to see what you all think. Thank you, Sosa, for the follow. Oh, cool. We're at 1K likes. All right. So we are going to go ahead and get started. So for those of you who are here on Saturday, I'm sure you're thinking, didn't he already do this? And the answer is technically yes, but if you remember from last time, I did a couple problems and then I just started drawing blanks. So, um, I went back, I did a little bit more practice myself, And now I think I am ready to go over some problems with you all. So we're going to start with a couple easier ones. Yeah, I fully agree, Hefe. They are tough. There's a reason why they aren't in VAP calculus curriculum. Though I think the next time they update the curriculum, I wouldn't be shocked if they include this in like the BC class. Yeah, I know, right? And I just learned that not every even in universities, not all the calculus teachers teach this. You hope not. Yeah, I hope not either. But I feel like that may happen. But who knows? I'm not a member of the college board, so I don't get a say. So, do I know any linear algebra? I do. Is there a specific topic you want me to cover, Ben? I'm going to focus on this tonight, but I'll add any topic that you want to my list from that class. You think they may? I think they may cut stuff out. Most of the courses are reducing the amount of unit stats. Wait, is this stuff right now Calc 3? Nope. So technically, you might see it in Calc 1, but you might see it in real analysis as well. That's why we're gonna stick to the easier problems. I'm gonna try to um, keep our advanced calculus stuff to a minimum tonight. Um, so I have two or three linear problems to go over, and then we'll do one quadratic, and I have one rational. I think after that we will see how it goes. That's this going. Yeah, I did. I read about that. Yeah, I did. I did read about that. But then again, what was it? L'Hopital is relatively new to the AP curriculum. I don't remember seeing that before, like 3 or 4 years ago. So that's why I'm saying if they do add these, if they're gonna add these into the AP program, I'll just add them in BC. I would not subject AB students to this. Oh, I love L'Hopital. It helps so much. It does. I fully agree. However, Ben, remember that in order to use L'Hopital, there are certain conditions that need to be met, and if those conditions aren't met, then um L'Hopital can't use L'Hopital. You're almost done with limits. Awesome. How far are you away from the Have you done the limit definition yet, or are you still a bit away? You just did that today. Cool. That's really cool. Oh, by the way, Hefe, I've been meaning to ask, how did that test go? You're just starting limits? That's cool, Dan. That's really cool. Um, are you Of course. Took both AP Calcs last year. Now I'm taking linear algebra, then calculus 3 for wow. Wow, that's gonna be something, Ben. It went really good. A lot. Tell your class I said congratulations. Of course, they probably won't know who I am, but hey, they still deserve congratulations, even the same. Okay, so let's go ahead and get started with our topic for tonight, which is Epsilon Delta proofs. They're a great group. I'm more than sure they are. So let me go ahead. Let's go ahead and define what the epsilon delta proof says. So I'm going to take the limit as x approaches some number a of f of x is equal to L. So what does this mean? Well, this says, remember that this says as x gets infinite, gets closer and closer to a, what the value L is what y would approach for the function. But tonight we're going to do something involving epsilon delta. So what does that mean? Well, the epsilon delta, I'm not going to write the quote unquote shorthand. I might if you're interested, but I'll write it longhand. So for all epsilon greater than 0, there exists actually let me I have the formal definition. I just need to get to it because I need to make sure I word it correctly. Oh, I forgot. I have it on what we did last time. There we go. So epsilon delta says, thank you S Point for the follow, and thank you Decay for sharing the live. So for every epsilon greater than 0, there exists a delta greater than 0, such that if the absolute value of x minus the value I'm approaching is between 0 and delta, then the absolute value of the function minus the limit is going to be less than epsilon. What does that mean? So as you can see, and actually, I might try drawing that again. So I'll draw a new function, maybe one that's a little easier to see. So I think that's about the middle. I always tend to underestimate where the middle is. Okay, that's not bad. So let's say I have the following function. Let's say that I'm going to use a linear function because it's kind of easier to show. So let's use that. So, and let's say that the value I'm approaching is right here. So we'll call that A. Can everyone see that okay? And therefore this would be f of A. So epsilon delta says for all epsilon greater than 0. So what does that mean? So no matter what value you pick for y, so let's say let's say I want to give a range of, so when I talk about epsilon, I'm talking about, or actually let me start this way. For any epsilon greater than 0, there exists a delta greater than 0, such that, might help if I write down the point. So such that delta, or the absolute value of x minus a, is less than delta if that exists, then the absolute value of f of x minus L is going to be less than epsilon. So what does that mean? So no matter what value of delta you give me, I can always pick an epsilon, or no matter what value of epsilon you choose, I can always pick a delta such that the following is the case. So I'm going to pick delta. This is, or actually this should be x. No. I'll let that be a minus delta and a plus delta. Coding if thens on pen and paper is like this, like it's the 70s. Absolutely. So I'm gonna do a bad job of my drawing, so I apologize. I'm gonna approximate this. So this will be f of a plus epsilon. And then this would be f of a minus epsilon. Of course, I'm not using a computer, so I can only draw draw this so accurately. But if you notice, no matter what value of epsilon I pick here, there's always going to be a delta that such that the limit will be in between. So that's kind of a visual why not on a PC. So I'm actually recording on a document camera. I guess I could use a PC, but I'm not. I'd have to get a program that could do this for me. Plus I need to work on my drawing, so we are indeed. So let's go ahead. So now that we've seen my bad drawing, and let's face it, I'm lucky if I can draw a stick figure. But let's go ahead and look at this from an algebraic standpoint. So let's start with our first example. So show limit as x approaches 2 of 3x plus 4 is going to equal 10. Hey, Math Tutor, how's it going? I was in one of your lives earlier. Unfortunately, my phone died and it took me a while to find the charger. I'm doing good. How about you, Math Tutor? So, how did I like the live? It was pretty good. Like I said, my battery died a little ways into it, so I needed to find my charger. So, here we need to prove this is true using delta epsilon or epsilon delta. I don't know why. And maybe this is true for other people, but for me, I don't know if it is or not, but for me, I don't know why I always mix up delta and epsilon, because delta comes before epsilon in the Greek alphabet, but it's epsilon delta, and I'm like, but I mess it up all the time. So if you hear me call it delta epsilon, no, I'm talking about epsilon delta. So here, I'm going to use 4 words to do this proof. So the first word is let. The second word is choose. The third word is assume. And the fourth word is thus. So let's go ahead and fill these 4 words in. So first, I'm going to let epsilon be greater than 0. Why? Because that's what we start with. For all epsilon greater than 0. So I'm going to start with that because it's given. The second line is going to be choose. So I'm going to choose a delta. But I don't know what delta is yet, so I'm going to leave it blank. And then from here, I'm going to assume that that this is true. So I'm going to assume that 0 is less than the absolute value of x minus a. Well, what's a? A is the value that x is approaching, which is 2. So I have x minus 2 is less than epsilon. And then thus, this is where the majority of our work's going to be. So I'm going to use this to eventually choose a delta. So let's go ahead and get started. So assuming this is true, then I can use this fourth part here, which says take the function, subtract the value of the limit, take the absolute value, and have it be less than epsilon. So what's my function? My function is 3x plus 4 minus the value of the limit, which is 10, and that is going to be less than epsilon. So now I'm going to go ahead and start doing the algebra to hopefully find something that brings me from here to here. Because once I can go from here to here, I can link my epsilon and my delta. So here, I can start by simplifying that. So if I were to simplify 3x plus 4 minus 10, what would be left? Or should I say, starting here? Almost, Dan. Right, math tutor, it would be negative 6. Right, why? Because 4 minus a 10 is going to give me negative 6. I'm left with 3x minus 6 is less than epsilon. That's okay, Dan. I like to think that you meant to type 6, but you accidentally typed 5. Thank you, math tutor, for the heart me. So now, what can I do here? Well, now I can take out a greatest common factor. Isn't this calculus, or what math is this, lol? This is Calc 1. Yep, you're right. So here, I can go ahead and factor out a negative 3, right? Why? Because 3x divided by 3 is x, and negative 6 divided by 3 is going to be negative 2. So, I have the absolute value of 3 times x minus 2 is less than my epsilon. Now remember from algebra that if I'm multiplying two things inside a set of absolute values, that means that I can multiply the absolute values together. So I can separate this as the absolute value of 3 times the absolute value of x minus 2. Nope, might want to close that parenthesis before doing that. There we go. Do you need to take trig before calculus? Yes. I would highly, highly recommend that you take trig before you take calculus, Caleb. Good question, though. So, remember what absolute value means. Absolute value means, or should I say, absolute value can never be negative. So, do I have to worry about? Do I need the absolute value in front of my 3? Yes or no? Or am I good to just get rid of the absolute value on my 3? Right, Dan. So positive 3 is always positive, so I don't need the absolute values there. So I'm going to have 3 times the absolute value of x minus 2 is less than epsilon. So now I can say what? I can say that I know that x minus 2 is going to be less than delta. Thank you, Zachary, for the follow. So then if I divide by 3, I have x minus 2 is less than epsilon over 3. But I know, so I have x minus 2 is less than epsilon over 3. However, if we look back here, we can also see that the absolute value of x minus 2 is also less than delta. So now I have a link between my delta and my epsilon. So now I'm going to choose delta to be epsilon over 3. Now, here's the thing about epsilon and delta. This can never be negative. Why? Why can it never be negative? Why can't delta be negative? Trig is definitely an important prerequisite for calculus. A lot of trig functions are involved. Correct. I'm a pre-med student in pre-calc. Thank you for sharing your knowledge with the world. No, you're welcome. You're most certainly welcome, Zach. Delta is a positive difference. We said is greater than 0 because epsilon is greater than 0. Right. So also remember that absolute value can never be delta is greater than this, but this is also greater than 0. Therefore, delta is always greater than 0. So therefore, delta must be positive. Does any medical professional ever use calculus? Never. How many? Actually, they do. So, later on in calculus, we're going to learn about this thing called optimization. And now I'm not in the medical field, but I understand that those who test medications want to maximize the benefit while minimizing side effects. So they use formulas in calculus like this to do that. So actually, calculus does have applications in the medical field. So where was I? Oh yeah. So here, now I have a link between my epsilon and my delta. So now, what I can do to prove this to be true yes, but your question said medical professional, so yes. Anyway, moving on. So now I can use this to show that to be true. How? So I can show. So now if I plug in that, so I have, where was I going with this? Oh, so if I plug in this, so now what I can do is plus 4 minus 10 is equal to the absolute value of 3x minus 6. And then from here, I'm essentially doing this over again. 3 times x minus 2, which is less than 3 delta, right? Because if I multiply the same thing on both sides of an inequality, it means that so if I multiply a positive number to both sides of an inequality, the inequality doesn't change. Thank you, Jay, for the follow. So from here, we know that we name delta as epsilon over 3. So that's going to be 3 times epsilon over 3. Threes can't. We say bye 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 to the threes, and we are left with epsilon. So, therefore, limit as x approaches 2 of 3x plus 4 is equal to 10. Q, E, D. And that's it. Any questions so far? I love your detailed proof. That's the way I was thinking all along. Thank you, Math Tutor. We're going to be seeing a few of these tonight. So let's go ahead and try another one of these. The question is, though, do I have enough room? I might have enough room for the next problem, but after that, I'll need to turn the page. So is calculus just more advanced order of operations? I wouldn't say so. It's more than that. So calculus is going to answer two main questions. One, how do I find the instantaneous rate of change? And two, how do I find the area under a curve? So those, I think, are the two major questions of calculus. But in order to understand the answer to the first question, we have to go through these things called limits. Do you think you could explain dependent vectors? So again, I'm gonna stick with this tonight, but I will add that to my list. Oh, here's my list. So dependent vectors. It's not calc, it's some linear algebra. No, I have other linear. I have a couple other linear algebra topics that on here anyway, so it's no big deal, Ben. I do want to get to linear algebra at some point. I want to learn math again. Using a calculator makes you forget stuff. So yeah, I think it's more of, here's my philosophy of what math is. Math is something that shouldn't be rushed. Math is something that's meant to take your time with. It's like doing a puzzle it's like doing a Sudoku puzzle or a crossword puzzle in the New York Times. You wouldn't rush through it if you didn't have to, right? So why do we rush through math? But yeah, that's just my humble opinion. But that's the reason why I love math so much. Especially, it's because when you slow down and realize that math is nothing more than logic and puzzles, because that's all problems are. But once you understand that, when I was a kid, I calculated the r in a cubic light year. Now I use now I use a calc. You know what? That's okay. That's okay, Caleb. We all have to start somewhere, and that's the most important thing. We all start somewhere, and yeah, I'll be honest. Some of the stuff that I learned, I forgot. But if you relearn it, I can almost guarantee you that it's gonna come back. Right now, I'm trying to relearn French. Um, and I took French in high school, but I haven't used it in years, so I need to relearn it. But some of the stuff that I used to know is that as soon as I see it, it's coming back. So that's the thing. Once you start doing math again, it's gonna come back. Hey, how much math is there? Like, if you were to guess how much modules you think there are. Are you talking about one particular class or math in general? Because math in general has a ton of branches. You could theoretically say that it has infinite. Yeah, math has a lot of math has a lot of branches. I'm only going through the calculus branch right now, and even then I haven't really started going through it really, but um that's the thing. Math is like a tree, and each discipline is its own branch, each with its own set of math that goes with it. So um I truly believe that no one in their lifetime will know everything about math. Thank you, Ben, for the follow. So yeah, welcome on in, everyone. So now let's try another one of these. So let's say that I want to find the limit as x approaches 3 of. Actually, let's do this. Someone give me a linear function. Ideally, something with a positive slope. Let's do. Let's do 6x plus 5 is equal to 23. Let's use the epsilon delta method to prove this to be true. So we have let epsilon be greater than 0. We're going to choose. Thank you, Jeremy, for sharing the live. We're going to choose delta to be something, but I don't know what that something is yet. And then we're going to assume that 0 is less than the absolute value of x minus a, which is less than delta. And thus, the following. So we have f of x, which is that. So we have 6x plus 5 minus my value, which is minus 23, is less than epsilon. From here, let's go ahead and simplify that. 5 minus 23 gives me negative 18. That is going to be less than epsilon. What do I do from here? What do I do from here? Why is the absolute value needed? Because that is what our proof says. Right, Jeremy. So I'm going to factor out a 6. 6. And I'm left with 6x divided by 6 is x. And negative 18 divided by 6 is negative 3. Might want to close that parenthesis first. Less than epsilon. Thank you, Caleb, for the follow. And then from here, what's going to be left? Well, now I don't remember that if I'm multiplying inside a set of absolute value, it means that I can multiply the absolute values together. Thank you, Ezra, for the roses. So that means I have absolute value of 6 times the absolute value of x minus 3 is less than epsilon. Thank you, Ashlyn, for the follow. And then remember, because I have a positive 6 here, I don't need the absolute value. So I'm going to do, it's going to be 6 times the absolute value of x minus 3 is less than epsilon. And then from here, as Jeremy suggested, I'll go ahead and divide by 6 from both sides. Because 6 is positive, I don't have to flip that inequality sign. So I have absolute value of x minus 3 is less than epsilon over 6. So now, oops, this should be x minus 3. X minus 3, not x minus a. So now I have a link between my delta and my epsilon. So now I'm going to choose delta to equal epsilon divided by 6. So now that I have that, if I did this again, what do I end up getting? So I get, so this is going to be, I'm going to start here. So this is 6x plus 5 minus 23. And really I should put these in parentheses before I put absolute values. Is less than epsilon. 6x minus 18. Less than epsilon. So then I have 6 times the absolute value of x minus 3 is less than epsilon. But remember, this is the same. Hey, Vivid, how's it going? This is the same as saying that this is less than 6 delta. I've been at war. I'm doing applications of derivatives. It's low-key kind of easy. I thought it would be harder. Okay, I'm glad you're finding it easier, Vivid, than you thought. So now, remember delta. I chose delta to be epsilon over 6. So this would be 6 times epsilon over 6. We can say bye to the 6's. And I'm left with epsilon. So therefore, limit as x approaches 3 of 6x plus 5 is indeed equal to 23. Q, E, D. Only hard calc unit was Taylor and Maclaurin series. Okay. Well, the thing is, difficulty is subjective. So, I mean, I found some stuff in Calc Hard. I found, when I first took it, I found related rates to be difficult. I found optimization to be difficult. I love derivatives. We're doing Extrema or whatever it's called. Cool. That's really cool, Vivid. That is really cool indeed. So now, I seem to have run out of room. So now it's time for me to turn the page. So, yeah, and that's the thing. A lot of people struggle to convert word problems into math. So, yeah. Let's try one more linear, and then we'll move on to a quadratic, and then one with a square root, and then we'll call it a night. So, let's go ahead. Find the following. So, let's find the limit. What's related rates? Implicit differentiation? There is implicit differentiation in related rates, yeah. So, basically, related rates asks us, okay, as one thing, how is something changing as some other things change at an instant? The limit as x approaches 5 of, alright, someone give me a linear function that we can use. Thank you, Rinder, for the follow. 5x plus 3? You got it, Vivid. 5x plus 3. If I plug that in, 5 times 5 is 25. 25 plus 3 is 28. So, let's go ahead and find show this using the epsilon delta method. So, let epsilon be greater than 0. Choose delta equals something. Assume that 0 is less than the absolute value of x minus a. What's my a? My a is 5, because that's the value that I'm approaching. Thus, the function minus my limit is going to be less than epsilon. So it's going to be the absolute value of 5x plus 3 minus 28 is less than epsilon. Work out the math and tell me what we should choose for delta. Off topic, but any advice with know when and which integration techniques to use in Calc 2? So it really depends on how the it really depends on the type of problem that you're running into. If it's a basic one, like say take the integral of x squared, then you use reverse power rule. If it's something a little more complicated, like where the derivative is inside and the function are together in the same integral, then use u sub. If and like I said, it really comes down to what type of what's going on beside the integral sign. And there are certain keys that you look for to find out which technique to use. My teacher didn't go over epsilon delta, then we skipped to derivative. Vivid, remind me, are you taking Calc 1 or are you taking AP Calculus? Because if you're taking AP Calc BC, okay. Yeah, so epsilon delta is actually not in the AP curriculum. In fact, some calculus teachers even in college don't show this. Mine did. But what was I going to say? Oh, so the yeah, you're not going to see this in the AP. In fact, I was having a discussion with someone earlier tonight, and I was saying if they add if they add this, they should add it only to the BC crowd, because AB AB is going to be this would be too much for the AB curriculum. I typed that horribly, but thank you. There are so many tech. Yeah, I know, right? And like I said, there are certain like that. It really comes down to how what's going on, and looking for those keys. I really struggle with these. I got a 3.3 out of 10 on my. I'm really sorry to hear that. I'm really sorry to hear that. Was it on this topic specifically, or is it overall so far? Well, McKenna, have a good first. Hopefully, you have a good first day of school. It's something similar to that. Okay. Um, what are you taking Calc 1 right now, or is it AP Calc? Then again, if it's AP Calc, you're not going to see this. So it's probably Calc 1 if you're covering Epsilon Delta. No, I'm a okay. Interesting. And you're covering limits already? That's interesting. What is the purpose of Epsilon? So the purpose of Epsilon. Now, we could have chosen. I didn't go to the naming convention back when it happened a long time ago. Um, so this is a way to show. This is technically the formal definition of the limit. So, like I said, if you're taking AP, you're not going to see this. But if you but if you're taking a Calc 1, some professors like to go over this. Mine did. Can you explain how to choose a delta? I have trouble with reason real and okay, yeah, sure. No problem. So, here's what I'm going to do. So, first, remember that I don't have to pick my delta immediately. I can leave this blank until I need it. So, I'm going to see when I need that. So, what I'm going to do is I start with this, and then I need to simplify it. So I have 5x plus 3 minus 28. So I have 5x. 3 minus 28 gives me a negative 25. And that brings me to epsilon. And that's still going to be less than epsilon. So now, what can I factor out of here? Right, Jake. Right, L Jr. Right, Vivid. It's 5. I can indeed factor out a 5. And do I have to leave the absolute value in front of a 5? Or am I good to just get rid of the absolute value there? Right, right, L Junior. Right, Pinhead Larry. Right, Jake. Right, Vivid. So because 5 is positive, 5 is always positive. I can ignore that absolute value, and I'd be left with x. The absolute value of x minus 5 is less than epsilon. And then from here, I'm going to go ahead and divide both sides by 5. So what am I left with? On the left, I'm left with the absolute value of x minus 5. And remember, because I'm dividing by a positive number, that inequality sign doesn't change. So it's going to be still less than epsilon divided by 5. Now, wait. The absolute value of x minus 5 is less than epsilon over 5. But if we look up here, it's also less than delta. So now I have a link between delta and my epsilon. So you were asking me how I choose delta. Well, I have to establish the link between delta and epsilon. And now that I have that link, I can choose delta to be this. So I'm going to choose delta to be epsilon over 5. What math is this? This is calculus. Yeah, not bad, right? Good one, Vivid. No, I'm not in calculus yet. Here's an example. Oh, so that looks like algebra 2. So I'm going over this tonight, but if you want, I will add that to my list. So um thank you, Vlom, for the follow. I think that's an L. Is this Calc 1? Indeed it is. And yes, you do also see these in real analysis as well. So rational expressions. That's what they're called. Do you go over the compactness of the reals ever? So it has been the last time I took or even seen real analysis was 2015. Um, I could probably, but I'd need time to go over it and review it for myself. I'm barely in AP pre-calc. This looks easy though. I'm glad. We're gonna get into a couple more complex one of these soon. But now from here, we are gonna choose delta to be equal to epsilon over 5. So now we're technically now ready to do the proof. So if I start here, 5x plus 3 minus 28 less than epsilon. And I'm just going to continue by going down what we've already done. 5x minus 25 less than epsilon. 5 times the absolute value of x minus 5 is less than epsilon. So remember, if 5 times something, so we can also say, on top of this, we can also say that 5 times this absolute value is going to be less than 5 times delta. So we can say that this is going to be less than 5 delta. So from here, I've already named my delta. What did I name it? I named it epsilon over 5. So this is equal to 5 times epsilon over 5. And now we can say bye to those 5s. And I'm left with epsilon. So now that I'm left with epsilon, I can now conclude that the limit as x approaches 5 of 5x plus 3 is indeed equal to 28. Q, E, D. Oh, I never covered anything like this in the calculus sequence. We say, okay, yeah, and like I said, there are some professors that don't teach this in their calculus class. Mine did, but there are some that don't, and they save it for real analysis. So I guess I'm technically going over 2 subjects at once tonight. I'm going over Calc 1, but I'm also going over real analysis a little bit. Do you cover any physics topics? I don't. I haven't done physics since 2011. I wanted to do physics in college, but I never got the opportunity to. Thank you, Momo, for the follow. Um, Yeah. When we get into velocity and acceleration, that's about all the physics that I get into when we cover that with derivatives. Cool. So I have a couple more that we're going to do tonight, and then um that'll be it for the problems that I have. So let's do another. We shall indeed. However, the likes look a little low. There are 12 of us in here. Let's see if we can't get to 3K likes before the next problem. Let's do a quick mad tap to 3K. Acceleration is like the second derivative and velocity is first. And I don't know anything else. I'm bad at physics. That's absolutely right, Vivid. Not the part that you're bad at physics, but everything. But the fact that velocity is first derivative and acceleration is second derivative is right. And to be honest, I haven't done physics since like I said I haven't done physics since I was a senior in high school, and that was almost 15 years. It'll be 15 years ago this June. Wow, that's really hard to believe. Thank you, Abdullah, for the follow. Yeah, I've been out of high school for 15 years next year. Physics is more or less conceptual. The more you take the time to understand what's going on, the math is very simple. Wow, okay. Fair. And here's the funny thing. Um, when it comes to my physics teacher actually wanted me to be a physicist. He spent my entire senior year trying to recruit me to switch from math to physics, and he admits to my parents, I've been trying to get him interested in physics and try to major in physics, but he loves math too much. So, well, I will say that was my favorite science class in high school. All right, so now we are past 3K. So let's go ahead and try another one, but this time, I'm sorry to hear that, Vivid, but I'm glad you like physics. I'm glad you love physics, rather. I shouldn't um underscore that. I have had Cal 1 and 3 and Physics 1 and 2, just have to do differential equations before my electrical classes. Fair enough. Thank you, Sunset, for the follow. Okay, so if for those of you who were here last time, one of these problems ended up stopping me in my tracks last time. So we're gonna try it again. We're gonna try one of these this time and see how it goes. So let's find the limit as x approaches 2 of x squared minus 1, and that equals 3. So let's start with our 4 words. Let, choose, assume, thus. So I'm going to let epsilon be greater than 0. I'm going to choose a delta, but I don't know what that delta is quite yet. And then I'm going to assume that 0 is less than the absolute value of x minus a. What's my a? My a is 2. Is less than delta. Thus, I have the absolute value of x squared minus 1 minus 3 is going to be less than epsilon. So here, I'm going to go ahead and simplify that. X squared minus 4 less than epsilon. What's my next step? Factor, right. What would that factor to? Carry the 1? Okay. I don't quite see where the 1 is. If you're talking about this one, I've already simplified that because negative 1 minus a 3 gives me negative 4. Right, Vivid. So it's going to be the absolute value of x plus 2 times x minus 2. Technically, user, you're right. But this is going to help us for our proof later. So, hey doll, how's it going? I'm glad to hear that. So, we're trying this again. So, now, remember, I'm doing good, doll. I am doing really good. So now from here, remember, I can split this up into the product of two absolute values. So I have the absolute value of x plus 2 times the absolute value of x minus 2. That will be less than epsilon. So, what do I do from here? Well, if I divide by x plus 2, what's going to happen? I don't have a value, a constant for that. So what I'm going to do is I'm going to assume, so we know that x minus 2 is less than delta. And we also know, this is where I have to go back to my notes for a moment. So I know that x minus 2 is less than delta. Is that the direction I want to go? Let's see. Let's see where it goes. So let x minus 2. So we know that's less than delta. So we know that by this definition, x minus 2 is between negative delta and delta. Yeah, let's see where this goes. It might not be the right way to do it, but we're going to see how it goes. So here, what I can do is if I want to end up with x plus 2 from x minus 2, well, I just add 4 to both. Add 4. But remember, what I do to one part of an inequality, I have to do to every part of the inequality. So here, this is going to be 4 minus delta is less than x plus 2, which is less than delta plus 4. So what I'm actually going to do is I'm going to go ahead and lower this value by putting in a negative there, or negative in front of 4. So I have negative 4 minus delta is less than x plus 2, which is less than 4 plus delta. Remember, in addition, order doesn't matter. So delta plus 4 is the same as 4 plus delta. So what I'm going to do now is I can factor out a negative sign out of net negative 4 minus delta. And I'm left with 4 plus delta, x plus 2, and 4 plus delta. So now, I can say by definition that the absolute value of x plus 2 is going to be less than 4 plus delta. So where do I go from there? So from here, thank you, Power, for the follow. So from here, if I divide both sides by the absolute value of x plus 2, well, I know what? I know that delta is greater than 0, so 4 plus delta is going to stay positive. So therefore, does it necessarily follow that that stays positive? Because if it does, x plus 2, left with the absolute value of x minus 2 is less than epsilon over x plus 2. Would that all? Yeah, it would. But the question I'm asking about whether it says it stays positive is the question becomes, can I get rid of the absolute value? So from here, remember that our idea is we want delta to be technically as small as possible. So I'm going to let delta be 1. I'm going to let delta be less than or equal to 1. So here, that would mean that x plus 2, the absolute value of x plus 2 would be less than 5. Wait, can't you square the binomial on both sides and then multiply them together? Where? Here? Because if I did, that just brings me back here. And it kind of undoes that step. Actually, either way, even if that stays negative, I can now choose no like x plus 2 all squared. Where would I be squaring x plus 2? Oh, okay. Yeah. So now from here, what I can do is now, because x plus 2 is less than 5, I'm going to go ahead and choose my delta to be epsilon over 5. I'm going to choose that to be my epsilon. Like that, I'm still not sure if this is even the right way, but we're going to go with it. So now that I've chosen a delta, let's see if we're right. So here, I'm going to start back here. So now that I've chosen a delta, let's go ahead and see what we get. So I have x squared minus 1 minus 3 is less than epsilon. I'm really hoping this is right. X squared minus 4 less than epsilon. This is going to be x plus 2 times x minus 2. is less than epsilon. We know that x minus 2 is less than 5. So we can rewrite and we know that the absolute value of x minus 2 is less than delta. So this is less, here we go, yep, this is right, 5 delta. But remember, we named delta to be epsilon over 5. So this is gonna equal 5 times epsilon over 5. Yep. We say bye to the 5s. And what are we left with? We're left with epsilon. And since that is our goal, therefore, limit as x approaches 2 of x squared minus 1 is equal to 3. There we go. There we go. Awesome. Any questions on this? Yes. I just proved it. Yeah. It's better than where we were Saturday night, where I was staring at a problem like this and I was just staring at it for 5 minutes. But we did it. That is a good question. So QED is a Latin phrase. It means it's quod erat demonstratum, and as it's translated in English, it's that which was to have been shown. And so the question then is why do I include that at the end of this? Well, it's because so if you ever read a formal math paper, you'll sometimes see at the end of a proof it says QED. That tells the reader the proof is done. You can use it for all proofs. Absolutely, you can. And I tell my geometry students, if you sometimes I just so I tell my students, if they put this to tell on a test or any of their proofs, to tell me what the teacher's reaction to it is, because it's kind of fun to see it. No problem, doll. No problem at all. And speaking of problems, I think it is time for the final problem. But I don't think I'm going to end it after that end the live after the problem. So there are 9 of us in here right now. Let's see. Oh, awesome. Hey, Tybalt, how's it going? So now there are 10 of us in here. Let's see if we can't get to 5K likes before the final problem. So let's just do a quick mad tap for the final problem. I believe that you can hit 5K likes. So yeah, I don't know if everyone saw it earlier, but a few hours ago, I posted a reel here on TikTok. It's all the topics that I plan to go over this week on my lives. What does everyone think about that? I have my final problem prep. Oh, here it is. Here it is. We are almost to 4,500 likes. Like I said, I know you all can get to 5K. But yeah. Almost there. I know you all got it. Welcome on in to those of you just joining us. We are going over the final problem for Epsilon Delta. So tomorrow, if I remember correctly, I think we're doing quotient rule. Or no, we're doing trig limit. We're doing trig derivatives first, and then quotient rule. So that is the plan for tomorrow. And then Wednesday, Thursday we're doing quotient rule. But yeah, we're almost at 5K. Almost there. I know you all got it. Almost there. Like I said, hopefully everyone's having fun. I'm having fun. Does it show who gives you the most hearts? It does not. It does not. Well, sometimes I think it would be kind of cool if it does. 5K? There we go. Perfect. All right. So, let's go ahead and solve the final problem of the night. So, limit as x approaches 4 of the square root of x minus 1 equals 1. So, let's write our 4 words down. So we have let, choose, assume, and thus. Thank you, Naya Yahoo Boy, for sharing the live. So, as always, we're going to let epsilon be greater than 0. We're going to choose a delta, but I don't know what that delta is yet, so I'm going to leave that there for now. And then I'm going to assume that 0 is less than the absolute value of x minus a. What's my a? My a is 4. Delta. And thus, I start with the absolute value of my function, x minus 1 minus 1. If I'm going to write 1 like that, I might as well use parentheses, is less than epsilon. I'm going to start here. So, now I'm going to start by simplifying. So I have the square root of x minus negative 1 minus 1 gives me negative 2. That is going to be less than epsilon. Now from here, if I were to, I want to get rid of that square root. What should I do to try and get rid of it? Well, I'm not sure if get rid of it is the right word, but well, if I times it by 1/2, it's not really, all this is going to do is give me 1/2 times the square root of x minus 1. Squared? Okay. Well, if I squared, I'm still going to end up with a square root. But you're on the right track. What's a surefire way for me to not have a square root here? Conjugate, yes! So what I'm going to do is I'm going to multiply this by its conjugate. However, remember, I can't change its value, so I'm going to do this. It's going to be the absolute value of the square root of x minus 2 times the square root of x. Remember, the conjugate is going to be the same thing as here, but the sign flips. This is x plus 2. And now I end up with difference of squares. Right, Alex, you're absolutely right. Although it's not square root of 2, it's square root of... Yes, perfect. Thank you, Proud, for the follow. So now, this causes division... yes, this causes division. Let's try that again. This causes difference of squares. I'm sorry. As you can see, I still make mistakes. Thank you, Proud, for sharing the live, and thank you, Alex, for the follow. So here, remember, I can rewrite that as that over 1. Thank you, Russ Lifts, for the follow. So now I end up with difference of squares. So that tells me it's root x times root x. It's going to give me x. And negative 2 times positive 2. That gives me a positive. Positive. Negative 4. And that's going to be all over the square root of root x plus 2. Now, would you agree or disagree with me on the following? I don't need to put an absolute value on the root x plus 2. What do you think? Do you agree or disagree with that statement? Hi, Uli. How's it going? You say agree? Absolutely. So plug in any number here that's not negative. Otherwise, this doesn't exist. Positive plus positive is positive, so I don't have to worry about the denominator having an absolute value. And again, because this is just multiplying by 1, it's still going to be less than epsilon. So now, what can I say about this? Well, I can say the following. I can say that absolute value of x minus 4 divided by the square root of x plus 2 is less than the absolute value of x minus 4 over 2. Do we agree on that? Do we agree on that fact? Or maybe it's not a fact. I don't know. I want to know what you think. Is that a fact? I should probably specify what I'm talking about. Is this true or false? Yeah, it's true, right? Why? Because remember, when you have a fraction, the smaller the denominator is, the larger the fraction is. It's like how do we agree or disagree on the following? We agree on this, right? So no matter so since this is always positive, no matter what I plug in for x, unless it's 0, but it's not going to be 0. But this is going to be smaller than that. So what I'm going to do is I'm going to go ahead and use this. So I can say that 1/2 times the absolute value of x minus 4 can I say that's less than epsilon? Yes, you're right, doll. It will add. So, but that means that this is going to be a smaller piece. The denominator is going to be more than 2. I agree with that. However, remember that the smaller the denominator is, the bigger the piece of pi, right? So if I have 1/3, I'm dividing the pi in 3 pieces. Whereas if I have 1/2, I have half a pi. And I think we agree that 1/2 a pi is more than 1/3 of a pi. Awesome. So from here, I now have 1/2 times x minus 4. Well, if we look up here, we know, or I'm sorry, the absolute value of x minus 4. If we look up here, I have the absolute value of x minus 4 is less than delta. So therefore, this is going to be less than 1/2 delta. So now that I have that, what I can do, I can say I haven't chosen a delta yet, but I need to link a delta to my epsilon. So this is going to be so. How do I want to do this? I know that I want to choose that my chosen. So I'm going to choose my delta to be 2 times epsilon. Why? Because of the following. So if I go back here, what's going to end up happening is that I'm going to end up with this being less than 1/2 delta, which I can say is, so I define my delta as 2 epsilon, so I have 1/2 times 2 times epsilon. We can say bye to the 2's, and that leaves me with epsilon. And therefore, the limit as x approaches 4, the square root of x minus 1 is indeed 1. Q, E, D. And with that, we'll call it good for epsilon delta. I'm not going to end the live though quite yet. Mostly because I want to know something from you. So, as I said at the beginning of the live, so as you can see, as you may or may not have seen on my TikTok page, there's a button to subscribe to my TikTok channel. I know that I think they're in the process of changing the subscriptions up a little bit, become super fans or something like that. But anyway, my question to you is this: if I were to turn on subscriptions, what are some things that you would like to see me include in the subscription? And I genuinely want to know. So what do you think? What would you like to see? Hard for that. You would like to see integrations, like the topic of integration, or um with Trig. Okay. So you're talking about I think I know what you're talking about. Yeah, I can include that on the list. I'm also thinking of doing a second live once my are you only dealing with real calculus right now? Yep. Only because I don't know how I don't know complex calculus. I've never taken a class in complex analysis. But yeah. So some of the things that I was thinking about, including to thank you Ace for the follow. So some of the things that I'm thinking about including I'm planning. I'm right like that right now. I'm looking at another time to do another live. Um, that'll be focused on other topics other than calculus. Also, thinking about doing a weekly live where we're not doing math, but just talking and about whatever, like what. So, one of the things that I want to so I'm called Robert the AP Math Guy. So one of the things that I want to do lives in are stats. Um, I'm trying to work like that. I'm trying to work it out with clients right now to see how their schedules go, but once they join back in, I'll have more of an idea of when that second live is going to be. Later, it's gonna be a little bit before I turn it on. I might turn it on though eventually. Or I might turn on the subscription. See how it goes. Anyway, so let's go ahead and call it an evening. But before I go, I have a few things that I want to mention. So, if you want to find me elsewhere, you can find me here, and here is my channel over there. And then if you do these 5 things, that would be awesome. I'm currently in the process of downloading all my lives that I've done so far since I think the middle of August. So you will find them here. Also, there are a couple other people on TikTok who I highly recommend you follow. So if you're looking to take your GED, your ASVAB, your Accuplacer, your TEAS test, or if you just want a refresher on Algebra 1 or Algebra 2 or Geometry, I highly recommend you follow ACG Math Tutoring. Audrey was the one who inspired me to join TikTok, and so I've been friends with her for years, and she is really awesome, and I highly recommend that you follow her if you don't already. Also, if you're interested in learning about the abacus, I recommend you follow Learning with Lynette. She's really awesome. That's actually where I'm going to be headed as soon as this live is over. So yeah, give those 2 a follow. And then I also offer online math tutoring. So I offer tutoring both one-on-one and in groups. So I'll start with the group tutoring. So group tutoring, it's I offer group tutoring to groups of 3 to 10 students who are all taking the same class at the same time. Now that doesn't mean you have to be taking it with the same teacher or even at the same school. It just means that you have to take the same class at the same time. So let's say you and 3 of your friends are all taking pre-calculus. Then you can all sign up for a group, and I charge $35 per hour per session. No, $35 per hour per person. And then I also offer one-on-one tutoring in any of these subjects. Now, if a subject's not here, that doesn't necessarily mean I don't tutor it. It just means that I need to refresh my knowledge of it before I tutor it. And yeah, so if you're interested in either group tutoring or one-on-one tutoring, feel free to DM me and we will set up a free consultation. So with that, everyone, have a great rest of your evening, and I will see you all tomorrow at 11:30. Bye now.